Okay, here's our test equipment when we get everything up and running. But on this side, you're gonna see the passenger side, bottom box right here. And then here's the insulation that goes in. And there's the rubber matting. Here's the rubber seal that goes on the edge right here, goes right here. And then these are the batteries that go inside the passenger side boxed on the lower level. And you can see the pre-made wiring harnesses. And then over here is the top box on the driver's side. And you can see we've already got our connectors in. That's the way it comes from the metal fab shop. And the bar that holds it, BMS, tester, and the insulation that goes on that one as well. And then here's the batteries that go in the top box on the passenger side, pre-made wiring harness, all pre-made separators, and then the pre-made bus bars there and there. And this is the rubber matting that goes inside that for shock. And so here's the driver's side. You can see the bottom box here, pre-made wiring harness. You can see the insulation, and the mat you can see is already in here with the brace bar. And then these are the batteries that go on the driver's side on the bottom box with the plastic separator on top. And then this is the top box on the driver's side. So you can see the insulation here, the brace bracket, everything in, the connectors in. And then you can see the batteries that go on the top on the driver's side, pre-made wiring harness, separators, plastic separators. And then you can see the fusing and bolts, and you can see the mat for the shock resistance there as well. So that's everything. That's going to be the entire kit that's assembled in less than a day. And we're going to start filming that now. Okay, here we are on final assembly. As you can see, we are hooked up to the entire BMS system here. And scroll down through here. So you can see we've got 213 cells, got a high and a low, got a 3.316 and a 3.46. So the 196 is giving us problems, but I'll show you how we're gonna fix that a little bit. So we get about 2%. That's been with about every single build. 2% of the batteries are not good. And this is the way you check them. You just keep this updated and balance them. So this is box number 1, which is the driver's side. And so this is the BMS. It's a BMS in each system. As you can see, we can put more batteries in here, and these can be mounted on the walls, and here's still plenty of room, making a 216 kilowatt hour battery pack. But you can see how this is set on the side of the truck. And the only thing you're gonna see is a high voltage cable coming out of here, going to your inverter and the front of the truck. Remember, this is on the side. And the only thing you're gonna see is this low voltage wire going up to the PDU. And then you're gonna have this plug, high voltage plug, which goes to the other battery box, which is over here because we're running in series. And then this is the communications, just a couple of wires that attaches to the other, and this is all your wires. This is it. The craziness of the wires is gone. So you have the high voltage connects both battery packs here and here. And then that other plug we were talking about connects right here. And this is where all the communication, I'm sorry, right here. This is where all the communication happens. Goes back in here, communicates with this. And that's what we're reading over there on that pack. And you can see this battery pack ready to go. Put this on here, then it gets an insulation packet up here, which you don't see. And then the lid goes on here as well. And you can see our waterproof design right here. And right now we've just got a simple machine that's just hooked up to power right here. All this mess will go away. And this is where we had an issue. This is our charger. And so we did have another cord in stock right here. But what happened, and is why another reason why we desperately need to be funded, is because we're using old equipment. So this unit is very old. This is a new one. This is Jeff's old one right here. This is a new one. It goes up to 1,000 volts. As you can see, but so does this one. But this one is not safe. This one would not allow what happened yesterday. This meter blew up on us. You can see where everything's scorched right here. And you can see it blew the cord. It's completely black, where you can see what a new one looks like. You can see it's all nice and shiny. But this is what happens when you're using old equipment. So we desperately need updated equipment, basically to stay alive. It takes a lot to stay under a $1 million budget, but as you can see, we're pulling it off, and it's much more advanced system. This system is got a better volumetric kilowatt than Tesla. So this is more advanced than Tesla right here for the size of the battery pack, because that can be 216 kilowatt hour, which I have not seen anybody do this to date. Okay, so let's go to the rest of the system. This is the starting of the motor assembly. As you can see, we've got all the cords set up coming from the pack. That's why we have the lid off, because we don't have the proper facility. We have to do it this way, but we're very safe. So we have disconnection methods that we use up here. So I literally can touch this while I'm working on it, but we use a certain method. But we just had to figure it out. We just don't have the expensive equipment that everyone uses. So you got a high voltage coming from your battery pack, which has got to go to your inverter right here. So you got your positive and you got your negative, and those are going to go into here. And we've got the lugs ready. We've got everything ready. We had to order the 4/0 wire. It's up to $10 a foot now. And as you can see, this is already wired, going straight to the electric motor. It's a very powerful motor. It's the most powerful one we've worked with so far. And then this resolver's already wired, goes in here. And we've got the cap for this. That's going to get cleaned up, but we're all set, ready to go. This is our power and CAN going to the inverter. And then we've got another set of CAN that communicates with the rest of the system. It communicates with the VCU, the vehicle control unit, which is a small computer, just like what the OEMs use, but this one's for electric vehicles. And then this is our throttle control. So we've got this all pinned up. And then to power our computer, we've got the 12-volt fuse, and this is how we power that. And from here, as you can see, that's pretty much our motor assembly, but there's one more component that you see that we have prepared. So here's the throttle. We're setting up the throttle right now, and that's got to be so many volts, and so we're testing this to make sure everything's okay. And this is the PDU. This is the most advanced, and we can honestly say that, a PDU on the market today, and it would rival Tesla completely. Because it's small. Jeff developed this board. We found very small components. It's very safe. You can see all the high power comes into here. We've got the battery for the truck, converts it from 700 volts down to 12 volts. This is our power steering, hydraulics, brakes, and power steering. And this is our AC compressor. So everything is solid state, everything comes in here. Everything comes in here. That mess you see on Lightning E-motor, we'll send that video. That's a complete mess. It looks like a rat's nest, but you can see once we get our lid on here, nice and neat that looks. That looks beautiful. Here's our high voltage coming in from the inverter. And here, this is coming in from the battery pack, big 4/0 wires. These wires are also fireproof. We have the most advanced system by far, but we need a better shop. We need more advanced technology to protect us. You see, everything's ready to be wired right here. Throttle, everything's done right here. And this is just the setup for when we get in Kansas. These are the high voltage connectors to the PDU box and to the battery boxes. And there's a special way you do this for a very high voltage. And we've learned along the years not to use plastic. We only use metal. And you can see this is the same system that GM Motors uses and probably Tesla, but GM definitely uses this connector, but not metal. We use metal because we build trucks, not cars. And it has to be rugged. So you can see everything's here. We're ready to go. And this is a very private video, so if you're looking at this unauthorized, please turn it off. This is a very private video, but you can see our shop. Everything is here and ready to go.